engineering project MeltSaver by Emily Kuzanik, Naomi Echo, and Zoe Atherton. In 2018, there were 273.6 million registered cars in the United States. During any month, temperature on average rises in a car by 40 degrees Fahrenheit per hour, making objects able to become very hot and sometimes even melt. According to a survey out of 294 randomly selected people, 78.54% said that during hot summer months objects melt in their car. Many of these people say that it often annoys them and feels the need to replace the objects when the situation occurs. In order to make sure this product was not already created, we looked on Google Patents and on Amazon to determine our competitors. These are some previous solutions that help cool objects down in cars. However, this does not meet our criteria. After researching, we came up with design requirements that we thought would allow us to create the best product possible. These requirements include: design must keep objects from melting or deforming, design must be easy and flexible to use, it must be cost effective, it must be able to work without electricity, it must be easy to install and low profile, it can't be too heavy or harm object, and design must eliminate deformation and annoyance. This is our design matrix for our final solution. In the end, we rated all of our design criteria on a scale of 1 to 5, with 5 being the best. However, in the end, our final solution was a mixture of all our original ideas. This is our first prototype, but it ended up being too bulky. This is our second prototype, however, it ended up being too sharp and too dangerous. This was our third prototype, however, it melted in testing phases. Throughout this project, we used multiple STEM concepts. To break it down, science was used in our engineering project to examine temperature, to research how insulation works and what materials would insulate best. Technology was used for communication and documentation. Zoom was a powerful tool, and the internet helped the research process be faster and easier. We also used technology to conduct our sample and create our 3D print design. We used engineering to create multiple visions for our finished product, go through the steps of the engineering procedure, and to use Onshape for our design. Lastly, we used math to look at temperature ranges needed for products and to measure and calculate the size of materials and cost. This was our first testing procedure. Unfortunately, our device only lasted 12 minutes inside the oven before the outside started melting. However, the inside insert stayed cool and did not melt, along with the Pocket Lab staying in the range of 60 to 72 degrees Fahrenheit. To make it easier for users and more compact in a car, we printed a smaller contraption to replicate our testing. Then we redid our testing procedure. After completing the second testing procedure, we came to the conclusion that both prototypes failed these tests. Despite our tests failing, we learned a lot from this project. Taking a look back at where we started with our first prototype and the one we finished with, it is apparent that the engineering design process helped us create a better product that had more of a chance at completing its job. We learned how to create drawings in Onshape to 3D print complex shapes while also using metals and other tools to create all prototypes.